Create parameters. In this video, we'll learn to create a list of user parameters and add them to our favorites. To get started, we want to make sure that we have Fusion 360 open, as well as our gear reduction parts and specs spreadsheet. Before we get started creating any detailed drawings or models, we want to make sure that we understand some of the nomenclature of what we're working with. So to get started, let's take a look at the three areas in our reduction parts and specs, first starting with gear parameters. There are a couple values that we need to make sure that we understand, as they'll be important later when we begin to create our gears. The first value is our module, and this module value is a size ratio between our pitch diameter and the number of teeth in our gear. For example, the module of 2 and the number of teeth of 48 is going to give us a 96 millimeter diameter gear. As we look through here, we have our drive, driven, and two different idler gears. When we look at these values, we can see that the number of teeth is giving us a 3-to-1 ratio. The idle gears are not going to affect the overall input and output ratio, but they will affect the direction of travel. So these are things we need to keep in mind as we begin designing our own reduction assembly. We have a backlash value, which will give us a small amount of space between gears. We have a root fillet, which is the rounded corner where the tooth of the gear actually enters the main body. And then we have our thickness value and the hole diameter in the center. The next section we have is for user parameters. The user parameters are going to be values that we create in Fusion 360 that can be linked to various parts of our design. We have our drive gear teeth, our driven gear teeth, the idle gear teeth, our module, the drive gear and driven gear diameters, our idle gear diameter, and then we have some various parameters for things like the mounting bolts, the flange, and the gear clearances. We also have a section called COTS. These are common off-the-shelf parts, and these are all McMaster car part numbers for things like bearings or hardware that we'll look at later on. So make sure that you have this list available as we begin to create our models. In Fusion 360, we want to make sure that we have a project and a location to store all our data. I've created a new project called 21 Modeling and Design for MFG or Manufacture. I've also created some subfolders, Basics of Modeling and Basics of Assemblies. We're going to get started on a new untitled document, and we'll be saving it inside of our Basics of Modeling. You want to check to make sure that you are using metric units, and we'll get started by going to Modify and selecting Change Parameters. Parameters are extremely helpful whenever we're starting a design that relies on external data. When I say external data, what I mean in this case is the fact that we know the size of our gears, we know various parameters about them, and some things like the amount of clearance we're going to need. So having these values predefined will make it much simpler when we start creating our models, and also it'll help us update the design later on. To create these parameters, we'll get started by selecting the plus icon next to user parameters and begin entering a new value. First, we'll start with the name. And in our case, we're going to start with our drive underscore gear underscore teeth. This is coming directly from our user parameters on that spec sheet. It's important to note that teeth in the context of our gear is unitless. It's not going to be a metric value such as a millimeter. It's going to be a numerical value that represents the number of teeth. So make sure that we do set the units to no unit, and the expression is going to be 48. We'll select OK, and we'll create another user parameter. Next, we'll be creating our driven underscore gear underscore teeth. Once again, this will be unitless, but in this case, I know that I'm working with a 3-to-1 ratio. So I'm going to begin typing the letter D, and then I'll select my drive gear teeth and simply divide that by 3. This is a wonderful way for us to create this parameter. That way, if we decide to change that 48 tooth gear to something larger or smaller, then we can keep that 3-to-1 ratio. Let's go ahead and add a few more user parameters. Next, we're going to talk about the idle gear teeth. So once again, idle underscore gear underscore teeth, changing the unit to unitless or no unit, and then setting this to a value of 10. Now we have a couple of these values. Let's go ahead and add our gear module. Once again, we're going to start typing this in with an underscore, making sure that we set any of these values that have no units as no unit, and we're going to enter a value of 2. We'll say OK, and now we've created our first 4 user parameters. The next thing that we want to do is we want to start to create some relationships between some of these values that we've already entered. As I've already mentioned, the gear module is a ratio between the number of teeth and the pitch diameter. So, number of teeth of 48 and a pitch diameter of 96 will give us a gear module of 2. Let's test that out by making a user parameter. In this case, we're going to start by typing in drive underscore gear underscore DIA for diameter. This will be a metric value, so we're going to leave the units at mm. I'm going to get started by placing 2 open brackets, and I want to start by typing the letter D, and I want to select my drive gear teeth. Remember, this is going to be a 48 and it's unitless. I then want to multiply that by my gear module. Once again, I'll start to type G. I'm going to close my brackets off, but we're multiplying a gear module and a number of teeth. Both of those are unitless. So I'm going to multiply both of those by 1 millimeter and then close my brackets. This is going to give me a value of 96, and because we multiplied it by 1 millimeter, we're going to have 96 millimeters. This is going to represent our drive gear diameter. Let's go ahead and create another one, and this will be our driven gear diameter. Once again, the units are metric. I'm going to start with those 2 brackets, and we'll start to type in driven, making sure that we have our driven gear teeth, multiply that by our gear module. And if you make a mistake, you can always back up by using the backspace. And again, we'll start to type in G for gear module, close the brackets, multiply it by 1 millimeter, and close off our second set of brackets. You have to make sure that you do include the asterisk for multiplication. That way it knows that it's multiplying it by that value. Simply putting it in brackets will not have it multiply those 2 together. Once again, we can check this with our spreadsheet, making sure that we are seeing 32. Let's go ahead and do this one more time. This time it's going to be for our idle gear. So idle underscore gear underscore DIA for diameter. 2 brackets, and we're going to start with our idle gear teeth. We're going to multiply that by our gear module. We're going to close our brackets and multiply that by 1 millimeter and close off the final bracket, giving us a value of 20 millimeters. So again, we can check those values and take a look at our spreadsheet to make sure that all of those values are matching. At this point, I want to make sure that you carry on with some of those other values in the spreadsheet, adding the values for our mount bolts, our idle gear shaft, our mount bolt flange, and our gear clearance diameter. Those are all going to be metric values, so make sure that you use the units mm. Before we go on to the next video, I also want to talk about creating favorites. As you begin to create complex designs, especially with large numbers of user parameters, it can be hard to keep track of them. Every time you create a sketch or some sort of feature, model parameters will begin to populate. So we'll have our model parameters as well as a large list of user parameters. So I like to use the favorites option by left-clicking on the star next to my user parameter, and that will put it up in a favorites category. This makes it a little bit easier to find when I come back to my parameters list. There are a few things that are going to be important to us. Things like the drive and driven gear values, our idle gear value, our gear module, as well as the various values for the diameters that we've created. Now in this case, I've added everything from my initial list to my favorites. That doesn't necessarily mean that you have to add all of them, but it is a good idea to make sure you understand how to filter and work inside of the user parameters, so that way you can make it easier to come back and change those values. These values will end up getting linked to sketches as well as feature diameters and distances, and these different values can be manipulated and modified directly in here. For example, if I decided I wanted to use a 60-tooth gear, you can see that that changes my driven gear to 20, and it also modifies things like the diameter of my drive and driven gears. If I reset that back to 48, everything goes back to those initial values. So it is extremely important that we understand that we can modify these values in here, and they will affect all of the different sketches and features that we're using. The last step here is to make sure that we do save this design. I'm going to call this my gear reduction housing. And I want to make sure to put it in my 21 modeling and design for manufacture. And I'm going to stick it inside of a basics of modeling subfolder and select save.